Yeah, I think it's pretty clear that it's the time of liquid funds. Having good tools and data for them is important. Next up, we have the amazing Arjun Bhuptani from Everclear talking about fragmentation from first principles.
Hello. Hi, everyone. My name is Arjun. I'm one of the founders of a project called Everclear. This is actually started at my last slide, so we're going to go all the way back. You're getting a little bit of a preview. I have been, a little bit about me, I've been working in this space since 2016 to try to figure out how we can fix some of the key problems that stop us from making Ethereum more widely adopted. Obviously, we have not yet succeeded, because otherwise we wouldn't all be here. This talk is called Fragmentation from First Principles. I want to try to dive a little bit deeper into what fragmentation actually is, because I think one of the biggest problems with fragmentation is that no one seems to have the right understanding of the problem in the first place. So, what is fragmentation? Unless you've been kind of completely out of the crypto Twitter sphere, you are probably aware that fragmentation is really the biggest problem that's facing Ethereum today. This comes from just the massive explosion of chains that we're seeing and the movement of liquidity to a bunch of different ecosystems. And really, what we need to try to understand is what underpins this trend. At the core of it is this original sin, where when we were first thinking about Ethereum, first thinking about ERC20s were not really designed to operate in a multi-state machine environment. Right? We had this idea of Ethereum at the time where Ethereum scalability was going to be centered around the sharding roadmap, where all of interoperability, all of scaling was going to be built as one unified thing. This is not what has happened. And it's good that this is not what's happened, because it's allowed us to expand a lot more quickly. But it has led to this pattern, where in order to bridge tokens to other chains, we have to do this really strange thing where we go and we put tokens into some sort of deposit contract, and then we mint a IOU on another chain. This sounds reasonable enough, but the problem happens when you're dealing with many different deposit contracts, many different bridges, many different rollups that are actually going and putting tokens on Ethereum into different places. Ultimately, at the end of the day, it doesn't really matter if you're talking about a burn and mint system or a lock and mint system. You are still depositing tokens somewhere. You're putting that value somewhere and putting it out of circulation. And if it's not in a place where it can be used as a in a single place where every bridge can interact with it, you have this form of fragmentation where a token that is minted by one bridge and a token that's minted by another bridge are different tokens, even if on L1 they are the same token. You can really understand this problem when you start looking at things like USDC. So USDC has this very interesting paradigm at the moment where CCTP allows you to burn and mint USDC between all chains. It's a fantastic experience. This is how we get to institutional level scale of liquidity movements between chains. But it doesn't work everywhere. And this is the big limitation of USDC today, where if you want to expand USDC to certain kinds of new chains or bridge USDC to certain new chains, for example, from Arbitrum to ZK Sync, you have to go through L1. You have to actually go and move liquidity back down to L1, go and lock it in the ZK Sync L1 bridge, and then bridge a representation of USDC, which is USDCE, on ZK Sync. Now, of course, USDCE is not the same as canonical USDC, and so when CCTP eventually goes and deploys to ZK Sync, you will now have two tokens, which is obviously a nightmare, as we've seen from just about every chain where they've done this. TLDR. Deposits are really what matter. All fragmentation on L2s really comes from the fact that L1 deposits are in different places. If you have L1 deposits in the same place, you can do things like CCTP, ideally without it being just controlled by a single central entity. But activities like shared sequencing, more interesting ways to move liquidity between chains, ways to be able to bridge arbitrary amounts at zero cost become available. And ultimately, if we actually want to solve the fragmentation problem, we have to find some way to mitigate this issue. OK, so TLDR, we are all building the same thing. Messaging protocols, L2 frameworks, RAS providers, shared bridges, everyone that's building an L1 deposit contract is technically competitive with one another, even if they don't want to be. Do intents solve this? Intents are, of course, a paradigm where you kind of have a solver who is this like mythical creature that goes and gives liquidity to a user on the destination chain immediately, so that as a user you don't have to think about bridging, you don't have to think about like going and interacting with an application somewhere else. But unfortunately, this actually just further this just pushes the problem to someone else. We kind of talk about this as like a game of hot potato, where like users go and give the potato over to bridges, and bridges give that potato over to solvers, and solvers give that potato over to sexes, and someone ends up having to take the L on fragmentation. Right now it's sexes with large deposit pools, but they are also kind of waking up to the fact that this is a problem for them. And so really, this is a Band-Aid solution, right? This is a way for us to fix this for users so we can go and figure out what to do on the back end. So how do we really fix fragmentation? Well, there's a lot of answers, but none of them are great. Option one is basically we kind of kill the entire interoperability roadmap. We kill any sort of like differences between L2s altogether, and we have everybody adhere to a single enshrined message transport that is a core part of Ethereum. This kills the superchain. This kills elastic chains. This kills like any sort of differentiation between rollups. It also kills every single interop protocol. But it works, and it actually would work and solve all of our problems. Unfortunately, this requires a shelling point, right? Everybody has to agree to use one deposit contract and one messaging framework. And of course, everyone goes and builds their own deposit contract and their own messaging framework, so you end up with 15 of them. This is unfortunately what's kind of happened with all of the different messaging systems and Aglair and et cetera, et cetera. Option number two, try to find some middle ground where you have a deposit contract, but you are interacting with many messaging protocols. This is also something that has been tried and unfortunately hasn't worked. There's an EIP that I actually helped write a couple of years ago called XERC20 that aimed to create a shared deposit contract on L1 for a bunch of different messaging approaches. Unfortunately, again, the incentives are not super well aligned, right? Because if you have a shared L1 deposit contract, you still kind of lose some of the like competitive advantage that you have as a project in this space. Another TLDR, the incentives around fixing fragmentation are really broken. And that's a big part of the reason why it's such a big problem. So what is the theoretical best solution? The theoretical best solution is we just sort of push everything back into L1, right? We make L1 responsible for sequencing like all of the rollups. We make L1 responsible for moving funds between all of the deposit contracts. And this is basically the based rollup proposal. But based rollups themselves suffer from trade-offs. And the big trade-off here is that it's a long time to get to prod. Right? We can't afford to wait around for several years for base rollups to ship. We need something that works today, and ideally something that is actually usable with things that are not going to adhere to a very specific specification. Right? So what happens for rollups that are posting DA elsewhere? What happens in the case where you have rollups that just don't want to become based for whatever reason? They just are kind of shut out of the system. So what is potentially helpful is to define more precisely what we are actually even looking for in a solution. And to be honest, there isn't a true answer to this yet, but at least understanding the problem for everybody here can help us get a little bit further. And what's missing right now is a solution that actually optimizes for two things, two very like present, practicable things. If you were here for Danny Ryan's talk, this is the time for Ethereum to kind of become practical, right? We need to figure out how to make this a usable product that can be sold to TradFi. And in order to do that, we need something that preserves sovereignty for all of the projects that exist today that are actually going and doing a lot of the BD efforts to go and work with a lot of Web2 and TradFi systems. And so this means preserving the sovereignty of rollup frameworks, of messaging layers, of Aglair, Superchain, et cetera. And then two, something that is actually usable today, right? Something that does not forecast out solving a set of research problems in the future that can potentially get bogged down in, unfortunately, what has happened with like ZK rollups. Right? ZK rollups are such a promising technology, but if we had not shipped optimistic rollups, we would still not today have any way to scale. So it's good that we had an interim solution in the meantime. I don't really have a real answer to this. This is like one of the most interesting and open problems in the space today, and if it's something that you're interested in talking about, definitely come find me afterwards. I have a hypothesis, and this is something that I have been working on with my organization, Everclear, but I think it's something that's starting to see a lot more traction elsewhere as well. People are starting to believe in this notion of netting. Netting is a process where financial systems basically find coincidences of wants between different parties in an ecosystem such that the total amount of movement of funds you have to do is a lot lower. So instead of having to go and bridge all of the funds that are there, you can't really see how much that is, but I think it's, I don't know, several million dollars. Instead of having to go and bridge all of those funds between these rollups, you can net and have them just move only a final amount of funds. I'm going to leave things there, and if you want to think more about this with me, then come talk to me afterwards. Thanks.